Here we're going to talk about atom economy. Now, the important things to know about atom economy are that it's a measure of the amount of starting materials that end up as useful products. Okay, so it's a percentage of this. And it always gives you the equation you need. But the really important thing is to look in detail at what the equation is actually showing. So it's the relative formula mass of the desired product, not of any product, of the actual product you want. And it's the sum of relative formula masses of all the reactants. Okay? So the word sum means addition. And all the reactants, well, that means everything you start with. So if you start with, for example, 2 hydrochloric acids, 2 HCl's, you have got 2 of them, and you use the 2 in the equation. Go on now for some more examples of this. So, we've got a question here from a past paper, which we're going to look at together based on this idea of atom economy. So, first off, you need to notice it gives you the equation, okay? Now there are some words in this equation that are really interesting to look at. So it uses the word desired product, okay? And it uses the sum means addition, of all the reactants. So let's just unpack what some of this means. So sum means we're going to add together. The reactants, well, that means all the starting products. And the desired product, well, these are the products, but only one of these is the desired product. So let's go back to the question. The equation for the reaction is here. It gives me the formula masses of all the different compounds. Now it says calculate the percentage atom economy for making copper sulfate. Therefore, copper sulfate is my desired product. So let's try and answer the question. Using the equation, I've got this relative formula mass of the desired product. Well, my desired product's copper sulfate. Tells me here is 159.5 divided by the sum of the relative formula masses of the reactants. So that's copper carbonate, 123.5, add sulfuric acid, which is 98. So if I do this, I have 159.5 divided by 221.5. It then says times 100. And this gets me my answer of 72.0%. There we go. So the question is, why is it important for the atom economy of a reaction to be as high as possible? Well, there are a few reasons, but the question says 1, so we'll just start with 1. It's important for economic reasons. As in, that means that I'm producing as much of the desired product as I possibly can, therefore I'm going to make the most money from it. I don't want to waste materials because I'm not getting anything for them. Another reason may be that waste products may be pollutants or greenhouse gases. So again, if my desired product is as high as possible, yes, I'm going to get more money for it, but also it means my waste product, it could be a pollutant or a greenhouse gas, I'm going to make less of it, which is another really good reason. So here's another example. This example is slightly harder. Pause it now, have a go, and then we'll run through the answer. So first thing to pick out, it's told me my formula masses. It's given me my equation again. It's talking about desired product, and it's sum of all the reactants. The reason I'm making this really clear is because this question is a little different, and it's saying for reaction 2, so we're only looking at this reaction. Now, earlier on in the question, it actually told you that copper chloride is the desired product. So now you know that, you've got a good place to start, because we've got our equation, the formula mass of the desired product. Well, that's this. And it's the sum of all the reactants. So here are my reactants. Well, I've got 79.5, add, because it's the sum. Now all the reactants, well, I've got 2 lots of hydrochloric acid, 2 lots of HCl. So I don't just have 36.5, but I've got 2 lots of that. Let's do it like that. So I've got 134.5 divided by 152.5 times it by 100. And this will get my percentage atom economy of 88.2%. Finally, I've got my 2 reactions, and the next question says the atom economy for reaction 1 is 68.45%, whereas we just worked out for reaction 2 it was 88.2%. So it says compare the atom economies of the 2 reactions for making copper chloride. This was my desired product. And give a reason for the difference. So I find this word really interesting because it's not actually told you what the difference is. So your first step is to say what the difference is. So the first step you would make is reaction 2 has a higher percentage atom economy than reaction 1. It says give a reason. So I've not actually got the mark yet because I've not actually answered the question. So the reason is because. Now, even if you're not 100% sure, you've got to use the information you're given. And the information you're given are the 2 reactions. So they've both got similar starting products. I know reaction 1's copper carbonate and reaction 2's copper oxide. They both make the same desired product. They both make water as a liquid, but reaction 1 makes carbon dioxide as a product, whereas reaction 2 doesn't. So this is the difference. So reaction 2 has a higher percentage atom economy than reaction 1 because an additional product, carbon dioxide, is made. So I've given a reason why, because instead of making 2 products, I've made 3, so therefore the percentage atom economy of creating the thing that I want is going to be lower. I've also been specific by saying what the additional product made was.